Today I'm going to be discussing PCR reaction miniaturization using the array tape technology from Douglas Scientific. For those of you who aren't familiar with array tape, it is a thin polypropylene consumable consisting of embossed reaction wells and serves as a replacement for your standard PCR plates. The working volume in these reactions is 1.6 microliters. Douglas Scientific offers two automated systems for processing samples in array tape, the Nexar and the IntelliCube. The IntelliCube positioned next to me is the latest evolution of the array tape technology and offers users real-time PCR capabilities. I'd like to start by describing how we set up reactions in array tape and compare that to what it would look like in a 10 microliter reaction on a standard system. Let's take a look at that 10 microliter reaction. It would typically consist of 5 microliters of a 2x PCR master mix, 1 microliter of your primers and probes, assuming a 20x stock, and the remaining 4 microliters would consist of DNA and water in variable amounts depending on your protocol. Now, in comparison, reactions in array tape, we typically add the primer and probe mix to the master mix prior to dispensing. The automated equipment then adds 0.8 microliters of your 2x PCR master mix containing the primers and probes and 0.8 microliters of your DNA or RNA sample to create that 1.6 microliter volume. Douglas Scientific has had a high level of success performing a variety of applications in this fashion, including SNP genotyping, copy number analysis, gene expression analysis, or DNA quantification with standard curves. Fortunately, if your PCR assay has been working well on your current platform, it's likely going to work well in array tape. We have a high success rate of converting well-established assays onto our system. Now, it's important to note that miniaturizing a reaction is not going to take an assay that has historically performed bad and all of a sudden make it work well, nor should we expect it to do so. One of the other considerations is your DNA sample. Array tape is compatible with a variety of sample prep methods, but you should consider your master mix choice, as many master mixes are more tolerant of PCR inhibitors and should be considered when using a more crude sample or only a partially purified sample. Sticking with the topic of DNA input, it is important to remember that we are only adding 0.8 microliters of your sample to the reaction. So if you're looking for a very rare target, you may need to consider an enrichment step or a concentration step. On the flip side, if your DNA sample is very concentrated to the point that it may inhibit the PCR reaction, we may have to consider a dilution step. Other parameters that can be tweaked on more rare occasions are the thermocycling conditions, in particular the annealing temperature, or the addition of certain compounds to the master mix. For SNP genotyping, we have found that the addition of certain additives can often improve cluster quality depending on the assay. Or, for standard PCR reactions, it's also possible to play around with the amount of magnesium in the reaction. Miniaturizing PCR reactions in array tape allows users to reduce sample volume and PCR reagents, increase throughput through the use of the automated equipment, all while maintaining the reproducibility and sensitivity you desire. What I hope you will come away with today is that the process of miniaturizing reactions in array tape can be very straightforward and effortless. And for those rare occasions where we have trouble, there are steps we can take to optimize and make it happen. So remember, when it comes to PCR reaction volumes, sometimes less is actually more.